Hi guys, Math and Logic here, and today we're going to be going over how you can solve trigonometry without the use of a calculator. By doing this, we are using something called exact value triangles. Very special things. They allow us to do some basic trigonometry, sine, cos, and tan without the calculator, and they will always give us exact values. So let's get right in. I will be using radians for this video, so if you don't already understand that, go to my video I posted that explains radians, and we'll go from there. So there are two exact values triangles. Exact value triangles are essentially just triangles that have certain units on them that allows us to do some trigonometry. So the first one is this. So we have a hypotenuse of root 2 and two equal side lengths of 1 unit. Now the angles for this is going to be pi on 4 and pi on 4. This is pretty obvious to see on an isosceles triangle. If you've got a right angle here, these angles are just going to be the same and going to add up to 90 degrees or pi and 2 radians. The next exact values triangle, slightly more tricky to remember. It's kind of a taller triangle here, still a right angle triangle, and this time we've got a hypotenuse of length 2. We've got this side that is length root 3, and then this side is just length 1. Now the angles on this one are a bit trickier, so we have got here pi on 3 or 60 degrees, and here we've got pi on 6, which is 30 degrees. Now I'm sure you can already see where we're heading with this. We've got all 3 angles available, all 3 side lengths available. We can use this to get some exact values for trigonometry. Let's do an example. So if we want to know the sine of pi on 4 or the sine of 45 degrees, we can write sine of pi on 4, because we know sine is opposite divided by hypotenuse. We can say that the sine of pi on 4 is equal to 1 over root 2. Now, what if we want to know the cosine of pi on 4? Well, cosine is adjacent divided by hypotenuse. So if we look at this angle here, adjacent divided by hypotenuse, we have 1 divided by root 2. Just like that. Tan of pi on 4. We know tan is opposite divided by adjacent, so if we look opposite the angle and adjacent, we're just going to get 1 divided by 1, which is 1. Now there is a step here you can do called rationalizing the denominator, which is where you times both sides by root 2 on 2, where you can get root 2 on root 2, sorry. So then you get root 2 over 2. And it just looks a bit nicer, but either way works. Anyway, let's move on to the next example, this second exact values triangle. Let's start with sine pi on 3. Opposite divide hypotenuse, we get root 3 divided by 2. And then if we do cosine of pi on 3, adjacent divided by hypotenuse is going to equal half. Tangent pi on 3. Root 3 is the opposite. 1 is adjacent, so we're just going to get root 3 over 1, which is just root 3. Now let's do pi on 6. So because the last time these two angles were the same, so these values will be the same each side, of course. So here we've got 2 different angles, so we can get 6 total values for them. So sine pi on 6, opposite divided hypotenuse, we're just going to get a half. Cosine pi on 6, adjacent divided by hypotenuse, we're going to get root 3 on 2. Tangent pi on 6, we're going to get opposite divided by hypotenuse, 1 over root 3. And if you rationalize this, you're going to just get root 3 divided by 3. I won't cover that in depth this video. But here you can see we've already developed 9 exact values for trigonometry, and I don't know whoever came up with this is a genius because it works really well. We'll do some checking here. If you were going to do sine of pi and 6 with a calculator, you would put in this calculator's in degrees, so we'll do sine of 30, and that's going to give me 0.5, and that lines up with our half here. Let's do something that's not going to give a nice number. We'll do sine. We'll do tangent of pi and 3. So I'm going to enter tangent pi and 3 is 60. And it's going to give us a number with decimals. Now, if your test or whatever example you're working with requires exact values, you can't use a calculator like this because it's just going to give however many decimals. It's not going to be as accurate as writing root 3. So we can put in root 3 here, and if that evaluates that, these are the same, 1.7320 whatever. These are the same. So this shows that our exact values have indeed worked. So that is how you can solve and evaluate trigonometry using these two very special exact values triangles. Okay, let's get into some examples. So this case, in these cases, we're solving for x, and in every one of these examples, even the challenge, this variable is going to be the angle. So here, what angle of x is going to allow us to get an exact value of root 3 on 2? Well, if we look back to our exact values triangles, root 3 on 2, we have to match up this sine and root 3 on 2. So here's cos of root 3 and root 2 on 2, but here's our sine. So we know that the sine of pi and 3 is going to be root 3 on 2. So we can go ahead and write x equals pi on 3, and that is the answer. Now, tan of an angle equals 1. Back to our exact values triangles, we know that the tangent is opposite divided by adjacent. So if you take the tangent of pi and 4, and that's going to be opposite divided by adjacent, so that's 1 divided by 1, it's just going to equal 1. So we can say x is equal to pi and 4. This next one, what value of x, or what angle is going to give pi and root 3 on 2, using these exact values triangles? Well, cosine is adjacent divided by hypotenuse. So if this is our adjacent, this is our hypotenuse, then the angle is going to be pi and 6. We can write x equals pi on 6. Now this challenge question is a little trickier. What we're looking for here is this entire angle. We can treat this entire angle in brackets, and what angle is going to give us our root 2 on 2. Now if you look back, this is just the rationalized version of 1 over root 2, and we know that 1 over root 2, opposite divided by adjacent, that's going to equal pi on 4. So we can say everything inside this, I'll put it in brackets just to show you, is equal to pi on 4. Now we just have to rearrange and solve for x. So 2x, subtract 1 from both sides, and then divide both sides by 2. So we can just times that by a half. Pi over 8 minus a half. These are some examples of the exact values triangles. Hopefully you've gained an understanding of how we can do trigonometry and evaluate it without a calculator and get exact values. Thank you very much for watching.